Hello everybody. Today I will be giving you some tutorial on using logical operators, logic bitwise operations, and increment, decrement, sum of statement with logical operators, a combination of them. So it will be a quick tutorial for everyone and especially for my students. Let me get started by creating a new project in Visual Studio. So this is the program. Once it started, let me create a new project by clicking over there. From here, I need to select empty project and make sure that it's the C++ part is selected. Then I need to click on next. Then after that, I need to name the project. I can name it whatever I want, but I need to make sure that it doesn't start with a number and it does not have any space or symbols. Then let's give it on the default name, which is project 2, create. Now the project is being created. This is the program. Once it started, we need to create a new source file. So you need to right click on source files and not resource files. So just right click on source files, add a new item. From this list, make sure you select Visual C++. You might have multiple things, but you need make sure that you select only Visual C++, then .cpp file. Then click on add. Same thing, you can name it whatever you want without space and without starting with a number. Then you need to click on add. Over here, we'll write our program or our code. So let us start with the default things that we will be having almost all the time. So hash include IOStream and using namespace std. So like what we said earlier, that you need to make sure that IOStream, yes, you need to make sure that you're writing it properly. Just like here, I made a mistake. You can see that it's giving me an error. Let me continue and let's see what will be the effect of completing with having the spelling mistake in the IOStream, what will affect our program. So let me continue. After that, we'll have void main. Then I need to open a curly bracket and close it, and at the end I need to put system pose. Okay, now I'm getting an error for system pose while it's true, where it's correct, it's not wrong. Also, if I even type cout, for example, hello, okay, still it's giving me an error. The thing is that the error is not from cout or not from system pose, is because I wrote IOStream with the wrong spelling. So let me type it correctly, IOStream. Now it's correct, all errors must go. So we can conclude from that hash include IOStream using namespace, we're importing the standard library for the input and output, which is cin and cout, and for the other stuff including system and so on. Okay, so let us remove the cout because we don't need it in our program. So in the first program, I will be just experimenting on the increment and decrement. So let me create a variable. Let's of the type of integer. So I'm creating a variable. Its type is integer, and let's call it x. And let's initialize. So we did just define the variable type of integer x. So since it's integer, it means that it can be an integer number, which is 1, 2, 3, 4, minus 1, minus 0, or 0, or minus 4, minus 5, and so on. Okay, it cannot be with decimal point. We'll have a decimal point, then we need to use a float. So let me initialize it with any number, for example, number 10. And over here, if I type plus plus x, okay, plus plus x or x plus plus, both of them, they're like what? What's called an increment. For example, plus plus x is equal to, which is like, and it's another representation of typing x equal to x plus 1. Okay, so x is equal x plus 1 is similar to plus plus x, and x is equal to x plus 1 is also similar to x plus plus. So what's the difference between plus plus x and x plus plus? We know that plus plus x will do the increment from the current command. Okay, so it will be incremented by 1 from the current command. X plus plus, it will be incrementing the variable x also, but not from the current line, it will increment it from the second line. The line we define it by the semicolon. Okay, so let us see what will be the effect. Now if I say cout x, and with end line, this is end L, not end 1, Let me run it. So I'm supposed to get which number? You can think about it. We started with 10. When we are incrementing it by 1, then we are viewing the value of the variable, okay, which is x. So we're supposed to get 10 plus 1, which is 11. Let me run it and see. So, like what we have expected, the number is 11. Okay, so let me close it. Now, even if I put x plus plus and run it, what do you expect to get? Of course, we'll be getting also 11. So, what's the difference between plus plus x and x plus plus? The only difference, like what we said, from the next line it will increment or from the current line. And in both cases, it's true we are changing the value in the memory, but we're not displaying it until we start a new line. Okay, since we started a new line, it doesn't matter whether we increment it here or over here, because both places will give us the new value. But when this will make a difference, when we do the increment on the same line, I mean the same line like what we said earlier in C++, the line is defined by semicolon or the end of the command itself. So if I put over here x plus plus, like what we have said, x plus plus will increment it from the next line. So if I run it right now, I'm supposed to get 10, but let me put another C out. So now if I run the program, initially x is equal to 10. Here 10 is incremented by 1. So 10 is incremented by 1, which is 11. But what will be displayed, because it's incremented starting from the next line, not from the current line, since it's x plus plus. Then the next line will be 11, and this line will remain as it is, which is 10. So we get 10 and 11. Let us check that. So 10 and 11, like what we have expected. The difference between x plus plus and plus plus x will appear over here. So if I put plus plus x, it will increment it with 1 also, but starting from the current line. So what we are expecting to have, we are expecting from the beginning x equal to 10, which is the initial value, then plus plus x. So x is incremented by 1, which is the initial value, plus 1. So what do we have right now? 11. So we are outputting 11, then the next line we're just displaying the value of x, which is 11. That was updated from the previous line, not from the current line. So here we will get 11 and 11. Let us run it and see, we're getting 11 and 11. So this is for the first part. Let me just copy and paste a code that I have, and let us check what does it do. So this is the code that we're having. The initial value of count is the variable which is similar to x that we had earlier. So let us analyze it and see what we will get. Let me get a notepad. So this is a notepad, and let me reduce the font size a little bit. Let us see what we'll be getting. So I'm supposed to get, let me put inside the memory, or let's just call it memory, and let's put output. So for the output, initially count is equal to 10. Okay, so starting from this line, count is equal to 10. Now the second line, we are incrementing it from the same line. Let me reduce the font a little bit in order to match the lines that we're having. Yes, I think I might need to reduce the font also a bit more. Yeah, I think now it's more than enough. So initially count is equal to 10. Now on this line we are having plus plus count. Since we're having plus plus count, we'll increment it from the current line itself, like what we said earlier. If it's the variable name plus plus from the next line, and the current line will remain as the previous value. But since it's plus plus the variable name, it will increment it starting from the current line. So it will be incrementing it from the current line. So 10 plus 1, which is 10 plus 1, which is 11. And what will be displayed is the new value. Line 1 is equal to 11. Now let's go to the next line. Now what do we have? We have count plus plus. So now the previous value of count is 11. But what we are doing, we are adding 1. So the increment here is not done from this line. It's done from the second line. So in the second line, I need to put 11 plus 1. The current line will remain the same. because it's count plus plus, the variable name plus plus. So here, what will be displayed when I output the data? So it will be line 2 is equal to the current value, which is 11, because it's count plus plus and the increment is done in the second line, not in the current line. So it's 11. Now, in the other line, which is line 3, like what we said, we got plus 1 from the previous value. So here what do we have? We have minus minus count, which means that subtract 1 starting from the current line. So it's 11 plus 1 and minus 1, which is, of course, 11. So what will be displayed over here is, again, 11. Okay, let's go to the line after that. Over here, what's the previous value? Where the previous value is 11, and we are subtracting 1 from starting from the same line. So it's 11 minus 1, which is 10. So line 4 obviously will be 10. Okay, again, line 5. Now for line 5, the previous value is 10. We are subtracting 1, but starting from the next line. So 10 minus 1 and the second line, but in the current line it remains the same because the minus minus is after the variable name. So what will be displayed for line 5? Line 5, yes, it will be 10 as well. Over here we have count minus minus again. So this is 10 minus 1, which is 9. In the line after that it will be 9 minus 1, because we're having minus minus. So it's decrementing it by 1 in the second line, because we're having the minus minus after the variable name. So what will be displayed for the line is, line 6 will be 9. And for the line 7, we didn't have any minus or plus, so it will take just the value that we're having, which is 9 minus 1, that's 8. And we'll display the value of line 7, which is 8. At the end, we're having the final value is count. Again, before that, we're having, okay, so before that, we're having count plus plus. So like what we mentioned earlier, when count plus plus or plus plus count comes in a single line by itself, it doesn't matter, because it will be incremented anyway, whether it's from the first line or from the second line. So it will be 8 then from the line after that, which is 9, that we are displaying it. So at the end we will have the final output is now is 9. So 3 11s, 10 10, 9 8, 9. Let's just check whether we've got that correctly or not. 11 11 11, 10 10, 9 8, 9. Is it the same? Yes, it is. Okay, so let us go to the next question. Okay, now I need to save it. So for the next question, we'd like to check the usage of less than or greater than with if statements. So before I start with that, I just want to emphasize on something. Let's assume that we're having two variables of type integer, x equal 1 and we have y equal to, let's say 2, no problem. So if I output x equal to 1, here you can notice that I'm having double equal. So when I have double equal, it means I'm referring to a logical operation. Okay, so I'm just checking a condition. If x equal to 1, if x is equal to 1, then what I will get over here, I will get 1, which is true, if the condition is correct and satisfied. If it's not true, what I will get 0. So here what I'm expecting, sorry, this is a mistake, I need to put comma. So here what I'm expecting is when I run it to get 1. Let me just change the value so you'll not be confused. If I put here 4 and here I put 4 as well. Okay, so is x equal to 4? What's the value of x? 4. So 4 equal to 4, yes, it's true, so I'm supposed to get 1. Let me run it and see. Yes, I'm getting 1. Okay, if I change it and I put is x equal to 3, which is not correct, of course, because x is equal to 4, 4 is not equal to 3. If I run it, I will get 0. Okay, same thing for less than or greater than, or even I can put x equal to y. Of course, it will give me 0 because 4 is not equal to 2. Okay, so it's giving me 0. And if I put x is greater than or equal, so it's greater than or equal, it's not the opposite. You don't put equal then greater than, you need to do greater than, less than, then equal. Okay, so this is the way you do it. It's correct because x is 4 and y is 2. We have greater than, we have less than, we have not equal. This term exclamation mark is for not equal when it comes with the equal itself. So if they are not equal, we will get 1 and so on. So I hope that's clear for you. So the difference you can see now, if I put x equal to y, what will I get? It's not giving me an error, so let me run it and see what I will get as an output. I'm getting as an output 2, which is x. This is assignment. This is like I'm assigning the value, okay, the value of y to x. So what happened? I said that x is equal to y. It's not checking, I'm not checking a condition. If I would like to check a condition, I need to put double equal. Okay, so here I'm trying to say that x is equal to the value of y. So what's the value of y? 2. So now x is equal to 2 and I'm displaying the result. That's why I got 2. I hope that's clear for you. And let me just copy the code and write it down for you, which is about the same idea. Okay, so this is the code like usual. Hash include IO stream, void main. These are just comments. You can remove them, you can put them whatever you want. We have two numbers like x and y. They're called number 1 and number 2. Then we are asking the user to just withdraw text to enter the first number and second number. Then we're checking these numbers. If these numbers they are equal, okay, so if number 1 is equal to number 2, we'll output number 1 is equal to number 2. If it's less than or equal, we will display less than or equal, and so on. You can notice that this is an if statement. If we have only one line following the if statement, no need to put curly bracket. If we are having multiple lines, then we need to put a curly bracket in order to contain the whole things that are inside the if statement. But since it's one line and it's simple, then we can consider it in our case without the curly brackets. Let me run it and see. Okay, I'm just running it. Here we have the numbers as an input, not as an initialized value or hard-coded value, just like what I explained earlier with the example of x and y. So enter the first number, let me say 3. Enter the second number, let's say 4. So of course 3 is less than or equal to 4, so this condition is satisfied. Less than or equal, condition of less than or equal is satisfied, so it displayed its value. Condition of not equal, it's also satisfied, so it displayed its value. Condition of less than 3 is less than 4 also is satisfied and displayed its value. I hope this question is clear, so let me go to the next question. For this question, and okay, for this question, let me write it down for you. Okay, I will bring it over here so you can see it. So, a speed detection radar emits a beam of microwave. Don't be afraid of all these fancy words. Okay, just what we need to identify is the variable names and any initial values if we have. We don't care also about the what's called the units because we'll not include it inside the program itself. So let me get started. So what do I have? I have an equation. Okay, its unit is mile per hour. I don't care about the unit like what we've said earlier, or I can just display it at the end as an output. Okay, output text, not as a variable. And here I have a multiplication. Okay, so and how many variables I do I have? I have fe. Fe is having a value initialized, so it's multiplied 10 to the power. So the best variable type for it is double, since we're having 10 to the power. And same thing for this one also, the best variable type for it is double as well. And fe and fr, we know them, and that's it. We have everything. We have no input over here. All the values are initialized and hard-coded inside our program. So let us start. Hash include and IO stream like usual. Then using namespace std, and let's start with void main. The system pause, of course, system pause we put it because the Visual Studio does not pause the screen once we run it. So if we run it through here, through clicking over here without putting system pause, the program will run and execute the commands and exit directly. So okay, so what's happening over here now? We need to define the variables which are fe and fr. Both of them, like what we said, they are of type of the type, their type is double. So fe is equal to e10. Okay, fe is equal to e10, which is 2 multiplied by 10 to the power 10, and we do have fr, which is 2.50410. 2.504 e10. Here we initialize the values and let us put the equation for v. Also, we need to define v, but will not initialize its value because it's calculated through the equation. Now, when we copy from Word, sometimes we will have some mistakes. Anyway, so this is multiplication. Let me put the multiplication sign. It's not x. So multiplication and subtraction. The one from Word, the formats used in Word, sometimes they're a little bit different, so they could give us a problem. And here we have multiplication. Okay, and we need the semicolon. Okay, so just I converted the equation. These numbers multiplied by these numbers. I cannot put them without multiplication because it's not calculator. Okay, so C out V and end line. Let me run it and see what I will get as an output. So I'm getting this number. Yes, so let me continue with the next question. Now for the next question, we'd like to deal with some assignment to operators. Okay, we just copy paste the whole program, then we'll discuss it together. Okay, so paste. Let's see this program. So like what you said, this is like a comment. Let me erase it because there's no need for it. And hash include iStream using namespace void main. So now we've defined a variable with a name of num and its initial value is 10 and it's of the type of integer. Now here we're having num plus equal 5. So what does this mean? This is equivalent to saying that number is equal to num number is equal to num plus 5. Num is equal to num plus 5. So it's similar. It's just like a shortcut since num and num are repeated. So what they did, they said that you can do it this way. Just remove all these and put plus equal. This way we're just doing it like a shortcut. So it's the same for multiplication. So num is equal to num multiplied, division, anything like that, or even percentage, which is the reminder. So here what we're having num, the initial value of num is, let me get not bad. So the initial value of num is 10. So here what I'm saying, num plus equal 5. So the value for num now is 15. So I'm displaying at the beginning expression 1, number 15. Then okay, so this is like an output. Then I'm saying num is equal to 10. So again, I reinitialize the value of number. So num is now 10 again. But then we are saying num is equal to num minus 5, which is 5. So now I'm displaying 5. Okay, then again, I reinitialize the value of num to 10. Now I'm multiplying it with 5. So num is equal to num multiplied by 5, which is 10 multiplied by 5. So I'll be displaying 50. Here division, 10 divided by 5, which is of course 2. And at the end we're just displaying the last value of num, which is 2. So let me run the program for you. Okay, so for the last term, it's not division, it's a percentage value. So for the last one, it's not division, it's a percentage value. That's why we got 0. So 10 divided by 5 is 2, and the remainder is 0. That's why we got 0 over here for the expression 5. Okay, so I hope this program is clear. Let me proceed to the next question. I'll give you a brief revision on logic. logic design. So these terms and is considered with logical ands, and yeah, no problem. Okay. So these double and signs for they're representing the logical and these two signs represent the or, and this one is not. Okay, so they're just logical operations. No problem. So these are just the logical operations. We are having them. If we'd like to check the condition whether it's uh, like and this person and that person, so we are having both sides must be correct. Let me check the tables so it will be more clear for you. So here the and itself, okay, if the first condition is not satisfied, which is 0, and the second condition is not satisfied, which is also 0, so both of them they're not satisfied, then the result of course is not satisfied. Over here one is satisfied and the other one is not satisfied, so of course the result is 0. So one is 0, one is 1. So the person X inside the room, person 1, person X is in, if person X is inside the room and person Y inside the room, we will get 1. So over here we're having one of them not inside the room, which is represented by 0. That's why we have the result is 0. So in general, and we need to have both conditions and both sides satisfied, which means that we need to have A and B 1. So the only case that we get and correct if A is 1 and B is 1. For the OR gate, what if one of them is valid, then the whole condition is satisfied. For example, if this person is in the classroom or the other person in the classroom. So if one of them is inside the classroom, then the condition will be satisfied and the result will be 1. But if both of them are outside, we will get 0. So the condition will be satisfied. That will lead to getting 0. So 0 and 0 is 0. 0 or 0 is 0. 0 or 1, one of them is satisfied, so 1, one of them is satisfied, 1, one of them is satisfied, 1. Exclusive OR is the operation when we are having both of them, they are different, so 0 and 0, they're not different, that's why we're getting 0. 0, 1 different, we're getting 1. 1, 0 different, we're getting 1. 1 and 1 not different, that's why we're getting 0. Not is the opposite or the complement, we call it the complement, so if it's 0, we'll get 1. 1, it's 0. Complement or inversion or anything like that. Okay, so like what we said earlier, 0 represent false, 1 represent true. Okay, so let me go through this program and run it, and let's see how we can check the output before running it. So let us check the output. So here we are asking the user to input the values. Let me erase the input part since I'm doing it far from you. So let us just put any value. Let's put here 2, let's put here 1, 5 and 1. Okay, so let's see which one of them will be satisfied. Now initially what do we have? We have these values. If I equal to j, let me copy the whole thing. Is I equal to j? What is the value of I? I is 2. What is the value of j? J is 1. From here I'm getting the values. A is 5 and B is 1. Okay, so is 2 equal to 1? Of course it's not correct, so the result is 0. Is 5 less than 1? Of course it's not correct, so the result is 0. 0 or 0? Of course it's 0 from the table that we got. So 0 or 0, of course 0. If one of them is 1, then we will get 1. So here the result is 0, so this part will not be displayed. Let us check the second part, whether it will be displayed or not. Now I is 2, j is 1, a is 5 and b is 1. Is 2 equal to 1? No, so 0. 5 less than 1, 0. So nothing will be displayed. Let me run the program. Will not get any output at all because none of the conditions are satisfied. So press any key to continue. No output at all. Let me modify the numbers that we've initialized in order to get an output. Let's put it 1 and 1. Okay, and let's put this. Okay, let me keep it as it is and let's analyze it together. So we said 1 and 1, and here we have 5, 1. Let me try to analyze it again. I is equal to 1, j is equal to 1, a is equal to 5, b is equal to 1. Is 1 equal to 1? Yes, of course it is. So the result is 1. Is 5 equal to 0? No, it's not. So 0. 1 or 0. If one of them is correct, we will get 1. So this thing will be displayed. First expression. Okay, and we're sure about that. We will check it together. And let me check the other part. Sorry, each minute I'm just stopping because I'm having people passing by. Okay, so I is equal to 1 and j is equal to 1, 5 is equal to 5, and b is 1. Is 1 equal to 1? Yes, of course. So 1 is 5 equal to 1? No. Less than 1? No. So 0. 1 and 0. Of course, both of them needs to be 1 in order to get the whole thing equal to 1. So 0. So only the condition is not satisfied for the second if statement, and we will have only first expression displayed. Let us run it and see whether what we said is correct or not. Of course, it is correct. Let me go to the next part. Okay, bitwise operations. For the bitwise operations, okay, bitwise operations, it means that it will deal with the data like if it was a binary number, bit by bit. Okay, so this is one and only, it's not double and, one or only, not double. And here we're having this symbol, okay, which is representing XOR. We're having this symbol, which is the complement, one's complement, which is converting it to negative. Okay, so you know that from logic design we have one's complement, second complement, first complement, second complement, and so on. So this one is one's complement, and here we can shift the registers by specific number of bits towards the direction of the arrow. So you can look at this one and just like if it's an arrow to directing towards the right side. Okay, I don't know the scheme whether it's giving you the opposite. Okay, so this one to the right side and this one to the left side. Let us try the program that we're having over here and see what do we get. Now we're defining an integer. Unsigned, it means that it's only in the positive side. It doesn't matter if I remove it. So it's just in the positive side. I'm defining an integer of value 60. Now this is comment. How did we get this number? Because here we're dealing with bitwise operations, so we need to be aware about its binary representation of this number. This number is in decimal. Okay, you know from logic design we have binary, decimal, hexadecimal, octal, and so on. So let me remind you. You remember from logic design we had some terms, okay, like 1, which is 2 to the power 0. Then we will have 2, which is 2 to the power 1, and we'll have 4, which is 2 to the power 2, and we do have 8, which is 2 to the power 3, and we do have 16, which is 2 to the power 4, 2 to the power 5, which is 32, and 64, which is 2 to the power 6, and 128, which is 2 to the power 7. 1, 2, 3, 4, 5, 6, 7. Okay, and we can have 2 to the power 8 and so on. But I think this is more than enough for our example because the number that we're dealing with is 60 only. Okay, so you can get these numbers either by putting 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, or just doubling the value. The double of 1 is 2, the double of 2 is 4, the double of 4 is 8, 16, 32, and so on. So here, I would like to get the value 60. Okay, let me get a calculator. So if I would like to get the value of 60, what do I need to do? I cannot use 64. The place where I will use, I will put just one. I cannot use 64, I cannot use 128 because both of them are greater than 60. So let me use 32. I'm using 32, so 60 minus 32. What do I get? 28. So I need to fill from this number 28. So if I take 16, I will subtract 16. Now I have 12. If I take 8, 12 minus 8 is 4. If I take again 4, okay, so minus 4, 0. So خلاص, now nothing is needed anymore. So just let me put 0 over here, 0 over here, and even I can put 100 zeros on the left side because they don't affect. Okay, but in our case we're considering 8 bits for our example, so let's just consider the 8 bits. You can see that this number is exactly the same as this number, 00111100. Okay, so this is just from what's called from logic design. Yes. So now we've seen that how did we get the now we have seen that how did we get the number 00111100, and it's similar to the 13 where you can do it by yourself. So we have A, B, and C. Now here we're having A and B. A ANDed with B. It's bitwise operation. It's not double A, not double AND. If it's double AND, then we will do logical operation, which we will check whether it will be just like logical operation. Yes, if both of them are satisfied. Okay, in our case it will be satisfied since it's not zero, but we don't need to bother ourselves about that because I cannot think of an example of it for now. For now, let us just see. Whenever we see one and, it means that we'll do bitwise operation. So we need to identify the 60, what is its representation, and we need to identify 30 because A and B. Now we need to do AND operation. What is the AND operation? If both of them are ones, we will get 1. 0 and 0 is 0. 0 and 0 is 0. 1 and 0 is 0. 1 and 0 is 0. 1 and 1 is correct, so we'll get 1. 1 and 1 is 1. Then 0 and 0. So the result is 0, 0, 0, 1, 1, 0, 0. So what do we have? We have 1 at 4 and 1 at 8. So 8 plus 4, which is 12. So we're supposed to get 12 over here. This is OR operation. Okay, OR operation. It's OR operation. When one of them is 1, we will get 1. So here we have one of them 1, 1. And here we do have one of them is 1. So then this number we can convert it to, again, to its decimal representation. This one is XOR. XOR when they are different. So here they are not different. Here they are different. Different. Here not different. Okay, not different. Not different, different. Okay, so when they are different, we'll put 1 for the bitwise operation. Okay, the complement, it will the first complement, it will convert it to the negative number. Okay, which is minus 61, also from logic design. This one is just shifting everything to the left. So this is A. What is A? We said A is 60, which is this number. Here we are shifting everything to the left by 2 binary numbers. So the last 2 binary numbers on the left side will be cancelled, and we will have padded zeros on the right side. So this is the number that we're getting, which is 240. Now if it's on the other direction, okay, if it's on the other direction to the right, again it will copy it. So the final 2 on the right side will be removed, and we'll have padded zeros on the left side. Okay, I hope this is clear for you, and if you have any question, please feel free to ask me. I'm here for you, and thank you so much.